Hi folks, we're going to take a look at the solution to question 2 from the second course review quiz. So here they're giving us two angles, x, which is in quadrant 2, and y, which is in quadrant 4, and they're giving us information about some trig ratios of these two angles. Okay, so they give us sine of x and they give us cos of y, and what they want us to determine is tan of x plus y. Okay, so here right off the bat we see that they're looking for something to do with the sum of these two angles, but they're giving us information about the individual angles. So that should lead you to use the sum formula in this case here for tangents. Let me start by writing that down. Okay, so we've got tan of x plus y is given by tan of x plus tan of y over 1 minus tan x tan y. Okay, so this is what we have to calculate, and we somehow have to use this information to calculate these different tangent values. Okay, and the way in which we do this is to use this sine value to eventually help us determine the tangent of x. Okay, now I suggest the best way to do that is to set up a little diagram here. So if we're working with the angle x is somewhere in the second quadrant. Okay, so now here be careful that x is representing an angle, okay, in the second quadrant. Okay, and what they tell us is that the sine of this angle is equal to 1 over 5. So think of the 1 as being the y value of a point on this terminal arm. Okay, so I'm going to create myself a little triangle there. So 1 represents the y value and 5 represents the r value. Okay, and what we need to do now in order to determine the tangent of this angle is to determine this adjacent x side. Okay, and of course the relationship between x, y, and r is just the Pythagorean property. Okay, so this side here is just given by the square root of the hypotenuse squared minus the other side squared. Okay, so 25 minus 1, so this is equal to root 24. Okay, but of course this just represents the side length of this triangle. Okay, keep in mind that what I'm looking for is the x value for this point. So in this case here it's going to be negative. Okay, so whether I just keep that in mind or I actually indicated here that it should be a negative value so I don't forget. Okay, but now that I've got all three sides for this triangle, I can now calculate tangent of x. So we have that tangent of x is just given by y over x, in other words negative 1 over root 24. Okay, and now we do the exact same thing for the angle y. So in this case here, the angle y is somewhere in the fourth quadrant. Okay, since I'm given the cosine value 1 over 3, 1 represents the x value, 3 represents the r value, and now to find this missing y value that I'm going to need, again, I just use Pythagoras. So the hypotenuse squared minus the other side squared, so that's just equal to 9 minus 1 is 8, so root 8. But again here, this is going to be a negative value, so I might as well just represent that right here. So the other thing I need in order to calculate this expression is tan of y, which now I can determine is y over x, so it's just negative root 8. Okay, and so now we've determined everything we need to calculate tan of x plus y. So now it's just a matter of inputting everything in here. So we have tan of x, which is negative 1 over root 24, okay, plus tan of y, which is negative root 8, all over 1 minus tan of x times tan of y. Okay. So at this point here, the last part is just to simplify this. Now the reason why I don't accept this as a final answer is I really don't want to see fractions inside of fractions. Okay, but what I'm not going to worry about is necessarily simplifying all these square roots. Okay, so here in the numerator I'm going to need to add, or in this case here subtract these two expressions using a common denominator of root 24. So this is what I have in my denominator for the numerator. So here I already have root 24 in the denominator of the first, so I've just got minus 1. Okay, and here I'm going to need to multiply root 8 times root 24. So that's minus, and 8 times 24, if you calculate that, is just 192. So this is going to be square root of 192. Okay, and now I'm going to take care of the denominator. So here let's simplify a little first. So 1. Now here, these two multiply to be a positive number, and so I'm subtracting a positive number, so this is going to remain a subtraction. And here this is going to be root 8 over root 24. Okay, now normally I would simplify this here, this fraction, but I notice that I've got a root 24 in the denominator up here, so I want to keep this denominator of root 24. Okay, that'll I think end up being helpful for me. Okay, so right now I'm not changing the numerator portion. Okay, and so now let's subtract these using a common denominator. And again, the common denominator is root 24, which I have to multiply to the first. So I have root 24 minus root 8. Okay, and here, these root 24s just reduce out. So in the end, I'm left with negative 1 minus root 192 over square root of 24 minus root 8. And that's where I'll say you need to stop. Okay, I'm not interested in you necessarily simplifying these roots, or I don't have a problem with you leaving roots in the denominator. Okay, but let's recap. The idea behind this type of problem is to see that you can use one of these, in this case here, addition formulas, and it's also to see that given information about one trig ratio and knowing its quadrant, I can determine the other trig ratios. In this case here, I use the fact that I knew sine x to help me determine tan x, and the fact that I knew cos y to help me determine tan y.